Hello class, welcome back. This tutorial will introduce how can we use loop to partition different training and testing dataset, and how can we use different training and testing dataset to evaluate the average performance for various classification algorithms such as decision tree and Nye Bayesian. So we're assuming you don't have any programming background, so we will briefly introduce the loop in R, and especially the for loop. So a loop is a sequence of statements that can be executed several times based on certain condition. While the body of the loop is obeyed a specific number of times, or for each of a collection of atoms, or until some condition is met. Well, there are two categories of loops. The first one is count-controlled loops, which include a for loop. The second category is condition-controlled loops, which is while loop, do-while loop. We will focus on for loop because that's what we will use for partition. So for loop, if you want to build a for loop, you will need to know the exact number of iterations you want before entering the loop. So there is always an explicit loop counter or loop variable. And so you have to state for the specific iterations and allows the code to be executed repeatedly. So on the right hand side, there is a flow chart, the for loop flow chart. So the loop counter here is I, and at first initial value for I equals to 0. And so the condition, there is a loop test. So if the values of I less than the values of this capital N, we will continue to proceed the loop body. And after the loop body, we will need to update this loop counter. Normally, sometimes the variable will be aggregated by 1. So this is one iteration. So for the next iteration, after the updating, I now equals to 1. So and then you came to the loop test here again. So if this I equals to 1, still less than n, we will continue to proceed. Otherwise, it will be exit. So for example, if the capital N equals to 5, so if the I still equals to 1, we will continue to proceed to the loop body. But after about 5 times of iterations, I now equals to 5, and 5 is not less than 5. So this loop test, the result of this loop test is false, and then we'll exit this loop. So that's basically the simplest loop flow, for loop flow. We will introduce a simple example of for loop in R, and introduce you a little bit of the for loop syntax in R. So now we will look at a simple for loop example in R Markdown. Well, we first define an empty list and give this empty list a name, number, and we want to fill this list with values from 1 to 3. So we now know exactly how many iterations we want to go through. It's 3, right? So the for loop syntax in R is using this for and parentheses. Inside this parentheses, we use this t to represent a loop variable, the loop counter. Well, you can replace this t with any names or any characters, it doesn't matter. And we use t in 1 column 3, means the loop condition is if the t is less or equal to 3 and larger or equal to 1, R will jump into this loop body and execute the R commands inside this body. If the t is less than 1 or t larger or equal to 3, larger than 3, it will exit this loop. So the initial value for t is 1, and after each iteration it will add 1. The t will increment value 1. So let's look at the body of this for loop. So now we have t, the initial value for t is 1. So when we print t, it will print value 1. And then the next step is we want to assign the value of this t to the element of the list at t index. So we want to assign value 1 to this to the element at the first index of this number list. And then when we print this element of the list at t index, which is at 1 index, it will also be output. It will also output number 1. And this is the first iteration. And after the iteration, t will increment by value 1. So t now is 2, right? And now if we print t, the value be outputted will be 2. And we will give number 2 to the element of this number list at index 2. And when we print out this number at index number 2, it will be output number 2. Again, number 2. And so on for the similar for the third iteration. So after third iteration, t will be equals to 4. So it no longer satisfies the condition here, like the range from 1 to 3. So R will exit the for loop, and we go to here. So when we want to print, this is the number, and when we print this number, it will have 3 elements. At the first index, we have the value 1, and second index we have the value 2, and at the third index we will have the value 3. So let's run this chunk, see if the results are the same as we thought. So these 2 ones are printed during the first iteration. These are printed during the second iteration, and these 2 are printed at the third iteration. So when we print out this list, we have the 1 at the first index, 2 at the second index, and 3 at the third index. Well, next, we will use a for loop in R Markdown to create n pairs of randomly sampled training and testing datasets. So first of all, we still need to load the library caret. And next, we need to define a list to store the n different training dataset, and we name this list data train. And also we need, similarly, we need another list to store the n different testing dataset, and we name it data test. Well, for now, you can have different pairs of randomly sampled datasets. Now we only need 3, so we give value 3 to this n's. And well, we want to calculate the average number of instances in the testing dataset. So here we initialize a variable called sum test cards, which will be used in the loop. And we want to use this one to calculate the average number of instances in the test datasets. So initial value for this variable is 0. Well, next, let's go ahead look this loop. So we want to have n different pairs of training and testing dataset. So obviously we have the specific number of iterations. So like I mentioned before, we use this I to represent the loop variable, loop counter, and we want the I equals from 1 to n, so it is in the range from 1 to n. So in total, it will have n different iterations. So in our case, we'll have 3 different iterations. In order to generate the random samples, remember to use the setSeed function. Well, because we want to generate n different pairs of different training and testing dataset, so for each iteration, we need to have different setSeed. We need to have different seed numbers. So, for example, if we want the seed number for the first iteration to be 100, for the second iteration to be 500, and for the third iteration to be 900, we can use this little calculation. So when the I equals to 1, we will have 100. When I equals to 2, we will have 500. And if I equals to 3, we'll have 900. So for each iterations, we'll have different seed number. Therefore, we will have different randomly sampled training and testing. Well, here we will still use this create data partition function to partition the training and testing dataset. So P is still equals to 0.67, which means 67% of our instances from the whole dataset will belong to the training dataset, and the rest 33% of the dataset will construct a testing dataset. And see here, we store our training dataset as an element at index I of the training list, which means if this one is the first iteration, we construct a training dataset randomly using seed number equals to 100, and we store this whole training dataset as an element of the training list we just create at its index number 1. So the first element of this list is our training dataset generated at the first iteration. Similarly, we store our testing dataset as the element at index I of the testing list we just created. Well, next, because we want to compute the average numbers of that inside this testing dataset, inside like 3 different testing datasets, so we will use the sum test cars. This variable was initialized before outside this loop, and at each iteration, it will add a new value in rows. This is the number of instances. The number of instances belongs to testing instance at each iteration. So after this whole loop, when the R exit the loop, some test cars, this variable, the value of this variable will equals to the total number of instances belongs to the testing dataset across 3 different iterations. And next, we want to print the proportion, generate and print the proportion for our target variable is by, and we want to print the title for the proportions first. So the title we prepare is the proportion table of trained data. See here, besides this phrase quoted by the quotation marks, we also add another I. So if we use a paste function, the R will print this phrase together with the value of I. For example, if this is the first iteration, it will print the proportion table of training data 1. And if it is the second iteration, it will replace this 1 by 2, so on and so forth. Well, next we will use prop.table to generate the proportion, the distribution of our target variable. And so these 2 lines are similar, just to create a title for the testing dataset and also see the distribution in our testing dataset. So in total, we will have 3 different iterations. When I equals to 4, it will jump out of the loop and jump to this line of our command. So now the sum test course, the value of this variable is the total number of instances of testing data set across 3 different iterations, we said before. And if we divided this value by n, we will get the average number of instances in the testing data set. So let's run this chunk, see if we get the correct results. So you can see the first one is the proportion table of training data 1, and there is a distribution of our target variable that inside the training data 1, and this is the proportion table for testing data 1. So on and so forth. So these outputs were generated at first iterations, and these are generated at the second iteration, and this is generated at the third iteration. So hope you have a brief idea of how this for loop works. And after the loop exit, we jump out to this line of our code, and then we calculate the average instances that belongs to test data set. So now we already have generated 3 different pairs of training and testing data set. Now we will build a decision tree model using this different training and testing data sets pair and generate the model performance, generate the average model performance over this 3 different testing data set. We want to calculate the average for the precision, recall, F measures, accuracy, and also the elements, the values inside the confusion matrix, the true positive, true negative, false positive, and false negative. So let's get started. So in order to build a C50 decision tree model, we need to load this C50 first. And also this R-minor package is used for M-metric. So let's load it again. So similar to the calculation of the average value of the number of different testing data sets, we want to generate the mean values of the elements inside this confusion matrix. For example, true positive, true negative, and so on. So now we initialize 4 different variables and give them an initial value 0. Well, next we need to define an array to store all the results. So this array, we name this array C50 total result. Well, next we will use a for loop similar to the for loop we used before, but this time we use this for loop to build 3 different decision tree model and evaluate this 3 decision tree model using 3 different testing data set. So similarly, this counter is in the range from 1 to n, which means we will have in total n different iterations. So in our case, we will have 3 iterations. Well, we use this for example, for the first iteration, we use this C5.0 function to build a C50 model, decision tree model. And we use the training data set we generate from the first iteration from a last loop. And then we use the predict function to predict the target variable is by for the instances inside the testing. Now, next, we will still use confusion matrix function to generate this confusion matrix for this to evaluate this model. And well, we will give this confusion matrix the value to a variable called C50 confusion matrix. And we, in order to compute the average values for true positive, false positive, true negative, and false negative, we first generate the sum values of these elements at each iteration with the new confusion matrix elements. So for example here, what does this table 2, 2, means? So let's check this confusion matrix. So here we got this confusion matrix. So the elements at the second row and at the second column is 96, which is true positive, which is the number of instances that has been correctly classified as positive level yes. So for the false positive, which is the second row, first column, so we have 12 elements, 12 instances that have been incorrectly classified as yes, the level yes, but actually they belong to level no. So at each iteration, we will add this the value of the elements from this confusion matrix to the sum variables. So after 3 iterations, similar to the loop we used before, the sum variable will have the total value of each element inside this confusion matrix. Well, next we can still use a metric function to calculate the metrics such as accuracy, precision, recall, and F measure. And we will, like, this one is only the result from one model, right? For example, if this first iteration, it is the result from one first model, and we want to combine the results for 3 different models. So we use this cbind function and to combine the results into an array. So remember, see here, this C50 total result is the array name. So after each iteration, this array will increasing with additional C50 results. So this C50 result elements will be append to this array. So let's run this for loop. And from the top, let's run this thing. And let's take a look at this array C50 total result. So you can see that we have like 3 iterations. So we have 3 columns of results. And the first columns are default none. So we can ignore this columns of values. Well, and in order to calculate the average of these 3 numbers, and so on, we will use a function called row means. And this is the array name. And inside this array name, we want to include the rows from 1 to 7. And we want to exclude the first column. So after this rows means function, we'll have only one column, which will present to the average of these 3, these 3, these 3, and so on. So let's run this rows means. So you can see that now we have the average values for the accuracy, precision, recall, and F measures. So next, we also want to get the average values of elements that inside this confusion matrix over the 3 test testing data set. So like we mentioned before, we can divide this sum variable by the numbers of iterations. So we will have now the average, the mean value for true positive, true negative, false positive, and so on. So let's check the values. So this is the true positive value inside the confusion matrix, the average value, and this is the true negative average value that inside the confusion matrix. Well, besides decision tree models, we also want to build the naive Bayesian model using the different training dataset and testing dataset, and we also want to compare the performance of naive Bayesian model and the decision tree model with the decision tree model. So the steps of building the models and testing the performance on the testing dataset are basically the same. Well, one thing we want to mention here is, besides using the library, the package E1071 to build a naive Bayesian model, we can also use the RVECA package to extract the naive Bayesian function to build a naive Bayesian model. So one thing is different from other packages. We need to first locate and define the naive Bayesian model from our VECA. So we need to method make VECA classifier and the location of this model, and then give this model a name NB. So now we can use this NB function to build the model. Also, similarly, we also use a for loop to go through 3 different iterations to build 3 different naive Bayesian models using 3 different training datasets and testing them and evaluating them using 3 different corresponding testing datasets. We also compute the average values of the elements inside the confusion matrix, for example, the true positive, false positive, and so on. And also we defined an array, and we append the NB result, which is the results from the M matrix, which are the accuracy, precision, recall, and F measures for each model. And we append this results to this array. So after the loop, so when our X is loop, this array will similarly have 3 accuracy, 3 precision, 3 recalls, and so on. Well, let's run this chunk. So now you can see that the NB total result is an array. It includes like 3 columns of elements, and then we use the row means similarly to compute the average values for each row, and also we got the average values for true positive, true negative, false positive, and false negative, and so on. Well, next we will compare the results from naive Bayesian models and the decision tree models, and we want to see which algorithm performs better for the target variable is byte by. And here we still use the cbind to combine the evaluations for 2 different algorithms, and we also use the row means to get the average value for the evaluation metrics such as accuracy, precision, and recall. So let's run this chunk and see the comparison result. So now you can see that the performance there is a huge performance difference in the precision for yes class. So the decision tree reached almost 88% precision, while naive Bayesian only have 47% precision. While for the recall, naive Bayesian model reaches about 30% of recall. However, the decision tree model only reached 22%. Well, this precision 2 and recall 2 are represent the evaluations for class level yes, which we know the yes class is a minority class. So there is a problem called imbalanced dataset problem we need to deal with. And that is all for this tutorial. Thank you for your time and thank you for listening. Bye.